everyone, thank you so much for joining. I'm Laura Schul, the CEO of Streetlight Data, and I'm joined by Teresa Tapia, who's our Senior Customer Success Executive here at Streetlight. Today, we're going to talk about our new bike and pedestrian metrics. Today in the webinar, I'll first do a quick review of who Streetlight is and what we do, because we noticed a lot of new faces, or I guess new email addresses in the login list. Then we'll review what bike and pedestrian metrics are available. Teresa will tell you about several use cases, and then I will tell you about the methods by which we determine what is bike or pedestrian in our data sets and the validation work we've done. And at the end, we'll take Q&A. So we think the first few parts should take no more than 20 or 30 minutes, which will give us plenty of time for your questions. So send them all in. All right. So to review, what big data are we working with when we say that Streetlight is a big data processing company? So on your screen, you see a video of raw pings from devices. The purple pings are the ones we're going to be talking about today. Those are pings from location-based services, apps. So what I mean by this is, if you have a smartphone, there are lots of apps that use location-based services for lots of reasons. Maybe they say, hey, congratulations, you took 10,000 steps, or turn left to get to the donut shop. We take these pings, we work with about 400 different apps, and we get them anonymized, and they're very big and very messy. And then we process those pings using lots of other data to infer patterns. So a simple pattern might be a trip stops here, goes by this route, and ends here. And a more complex inference, some of the ones we're going to be talking about today, that trip was probably taken by a bicyclist or probably taken by walking. So we'll get deep into the methods in the final part of the presentation, but I wanted to make sure everybody knew the core of where we were coming from before we got started. So at Streetlight, we process trillions of points like the ones you just saw to measure how pedestrians, bikes, and vehicles all interact. So you can do a lot of things with measurements like this. You can measure mobility for any road, any bike lane, any sidewalk in just a few clicks. You can understand origin and destination of the bikers, vehicles, or pedestrians taking that path. That can help you make a lot of important decisions. And some of the decisions we'll be focusing on today are how to deploy the right infrastructure in the right place. And lastly, you can use big data to manage some of the new mobility and complexity that's emerging, especially in our cityscapes, but also in our rural and suburban areas. All the different modes happening and sharing the same roadways leads to a pretty complicated situation, and having the right metrics is important. So, in summary, we take all of this geospatial data, we merge it with lots of other types of spatial data to calibrate data about the road and bike lane network, data about land use and demographics. We send it through our processing algorithms, and the way you, our customers, access this is by logging into the Streetlight On-Demand platform. So Teresa will walk you through at a high level how you get access to bicycle and pedestrian metrics through that platform, and there's lots of other online videos and demos if you're new to the Streetlight system. But the goal of that platform is to give you customized, actionable transportation analytics for a variety of metrics, which you see to the right. So with that, I'm going to turn it over to Teresa, who's going to tell you about what's available for these modes, how you run it, and then go into some case studies.
Thank you, Laura. Well, first of all, I do want to say that from my experience as a transportation planner, I can tell you that there were so many days when I was working for the city of San Francisco where I wished that I had had reliable bike and ped data to better plan and design the streets. So it's very exciting for me to be at ground zero and be a part of the team that is leading the charge and bringing big data analytics for active transportation to the industry. As Laura mentioned, Streetlight Data launched our bike and ped metrics at TRB earlier this year. And since then, we've been working long and hard to bring you a full spectrum of bike and ped analytics. This graphic gives you a nice, simple representation of what you can analyze with Streetlight Insights. For example, with just a few clicks, you can run an activity analysis to understand which neighborhoods have more people walking. You can also run an OD analysis to understand the top origins and destinations for bicycle trips leaving your downtown business district. And just like you can understand route choices for vehicles, you can now also understand how bicyclists travel on your streets with our Select Link tool. With all of our analytics, you can always add trip and traveler profiles to help you understand what types of trips people are making, for what purpose, and whether those trips demographically represent your cities. For those of you who already have access to Streetlight Insights, the bike and pet analytics are available in the multi-mode subscription tier. You use a similar process to run projects by setting up zones and navigating over to Create Project, and here is where you will find the drop-down menu to choose bicycles or pedestrians as a specific mode you'd like to analyze. And to show you how you can use our metrics to help you answer important questions about how bicycles and pedestrians are moving around in your city, I will walk you through some great case studies. I'm going to start with one that has recently received a lot of press. It centers around York County and the HRTPO in Northern Virginia. The county had a hypothesis that many of the users of the bike trail network were tourists, and thereby having a positive contribution to the local economy, beyond providing safe access. In order to justify investing in these trails, the county used Streetlight Insights to not only prove that there was heavy bicycle usage in the area, but that a large percentage of those users were tourists. We ran an analysis on the bike trail users, and based on the zip codes where people were living, policymakers were able to confirm that about 50% of trail users lived more than 100 miles from the town. In other words, they were tourists from other parts of the region. So not only was the bike trail popular, it was also attracting tourists from far away, and therefore investing in the trail system would boost economic activity generated by the tourists. That point was key in the presentation by HRTPO to county officials and was what got picked up by the press as a positive motivation, as you see in this headline. On another topic, many cities are interested in overall improving their bicycle networks, just like Lawrence, Kansas, but may need additional information about where investment would be most fruitful. Here we have another example in which we look at a classic bicycle network and use big data to help identify potential gaps. Now, this is a hypothetical case. We picked Lawrence because they have the top Google results for shapefile for existing bike lanes, and to tie in a little with the March Madness going on right now. To start with, this is a nice illustration of the existing bicycle lanes in Lawrence, Kansas. We ran an analysis on bicycle activity on the local streets to determine where potential network gaps existed. Here you can see that some streets have more people riding bicycles than others, as indicated by the thickness of the purple line. When we overlaid the bicycle network, here's another look at the bicycle activity with the white background. The purple segments jump out even more. When we overlaid the bicycle network, the orange lines here, with the bicycle activity generated from big data, the purple lines, certain corridors really jump out as areas where there may be gaps in the bike lane network. These roads, for example, could be potential candidates for bicycle upgrades, such as share roads, which have become increasingly popular in many cities. I want to bring your attention to the center there, particularly the purple circle area that you see in the middle. There. This street is called Massachusetts Avenue, and the thickness of the purple lines caught our attention. Looking more closely at the gap location, Mass Ave, we definitely noticed bicycles using the corridor. We also noticed that the corridor is quite wide, and the street parking may be underutilized. As a result, Mass Avenue could be a good candidate for bicycle improvements and potentially a road diet. But of course, this is one of many inputs in the process. We don't want to be a robot that dictates investment. We want to be able to quickly and accurately triage priorities so planners can get to the harder, non-data processing part of the process faster. I want to end with an example that touches on train station and accessibility. It's a topic that we discuss every year at conferences, including Revolution. And that is how do we facilitate easier multimodal access to transit stations. And one of the first questions that us planners often ask ourselves is, well, there aren't enough funds to improve every station, so how do we even begin to prioritize? So as an example, we picked the red metro line in Minneapolis. We analyzed 4 stations along this route, and it was very clear this one had the most pet activity, and the picture shows some of the reasons why. At first, I thought the data was indicating that more people were walking from the western part of the station, but upon further inspection, we noticed there was a giant park and ride. So there were trips being generated here, but they were not necessarily from the neighborhood, and instead, they were as a result of the people walking from the parking lot. This is a positive and a negative. The positive is that we at Streetlight are able to capture very short trips. The negative is that these trips do not correlate well with traditional survey methods, which do not typically capture this type of modal travel. So planners just need to be mindful of this when running an analytics with big data. The quick fix would be to simply envelop the park and ride part into the destination zone, and then you can get more precise understanding of where travel is coming from the neighborhoods. And with that, I'll hand it over to Laura to talk through our methods and validation.
Thanks, Teresa. Sounds great. All right, so we were going to go straight into QA, but we're pretty sure the first question is going to be, how did you know it was biking or walking? So we thought we'd dive into that now. So we will walk through our methods and validation, but we also want to remind everyone that after the webinar, everyone will be sent a link to these slides and also to a more in-depth white paper that goes through methodology and validation in more detail than we have time to today. So our goal is to be as accurate as a temporary count or a survey that covers bicycling and pedestrian activity, but we want to be available everywhere, be affordable, and be able to be clicked through and with answers received in just a few minutes and updated frequently. So that's the framework we are headed towards. So the first step in inferring bicycle and pedestrian metrics was to pick the right data. So we looked at a lot of different options, and the conclusion was we need a lot of different data. So fundamentally, we excluded cellular network-derived data, so that's data triangulated from cell towers, because of poor spatial precision. And if you're trying to measure short trips, like pedestrian trips, that just knocks it right out of the candidacy. We also looked at some pings from ads network-derived data. Those pings tend to happen very infrequently, like maybe once a week, so that also wasn't going to work. So we came back to the LBS data, which is data that's pinging in the background of smartphones, even if the apps that we're working with are not pinging in the foreground. Most of our smartphone apps ping at least once a minute, so you have a pretty quick cadence. But how do you know if it's biking or walking or in a vehicle? In theory, vehicles go faster than bikes and pedestrians, but as we all know, in a downtown environment, that's not true at all. So we couldn't use a simple thing like speed. We had to find a way to learn to recognize what I like to call the cadence of biking and walking and how that's different than the cadence of vehicles. So to do that, we had to find some truth data. To find this truth data, we looked in 2 places. The first place was GPS travel survey enhancement files. So that's something that a lot of states, including California, have done, where when they do a household travel survey, they also have a small panel of people who carry around GPS devices, and at the end of the day, go through and say, okay, yeah, that trip was walking, that trip was biking, then I took a bus, then I took a car. So that gave us a lot of truth. And we also worked with some data from apps that are particular to certain modes, like bike share apps. So we know when people are actively using the bike share app, they're taking a bike ride. So that's how we trained our machine learning algorithms to recognize the cadence of biking and walking and how it's different from the cadence of driving. And then to validate and check ourselves, we looked at counters, permanent counters, and traditional survey data. I'm going to walk you through all that quickly, but so I hope it gives a good idea of the general ways it works. So first, the machine learning. So that's what ML stands for. We used a type of machine learning called random forest, which is why you see this pretty forest over to the right. And basically, that's a way of looking at a lot of different features of data to recognize a particular type of behavior or classification. So we want to give a shout out to the National Renewable Energy Lab. who has saved in a secure location all the raw data from these household travel survey enhancements. And if you go through a process and use the data in a protected environment, you're allowed to research with it, which is what we did. So we used a lot of training data, but one of the things about it is that training data usually came from big GPS loggers, which ping every second. And our data doesn't necessarily ping every second. It's more like every half minute to a minute. So we had to impoverish and beat up on the training data to make it look just like our LBS data. So that's why you see the difference between points that were in the system and the final harvested points that we used to train our machine. Next, we had to group the pings into mode-assigned trips. Oh, and by the way, in this new world, we call stationary, which you could also call doing an activity, a different mode of travel. But usually the machine isn't dead certain. We're not 100% sure that a point is walking. So what we did is as we see the pings evolve over the phone's activities, we assign probabilities. So in this example, I just gave 2 modes. Actually, there are many it looks at. But as you can see, this series of pings is dominated by high probability walk pings. And then that probability starts to fall off, 60, 50, and the dominant probable mode switches to stationary. That's what we call the transition state, where we recognize someone goes from walking to being stationary. Now you might say, well, what if they just had to wait for the crosswalk? We don't just allow it to switch if one ping is stationary. We look for a predominance of modal shift before we will end a trip or switch to a new mode. Next, we have to lock the trips to available networks, because if you want to analyze a bike lane, you can't be sure that it will exactly ping exactly where you click on the bike lane. And this is something we do all the time for vehicle trips, but it's actually a little more tricky for bicycle and pedestrian trips. So what we did is we assumed that bikes and peds can go anywhere a car can go, even on highways, because as we talked to a lot of our clients, biking on highways was something they especially wanted to measure, as it happens a lot, especially in rural areas. And we also don't assume that the bikes and pedestrians follow the one-way rules, even if they're bike lanes. So basically, bikes and pedestrians can go pretty much anywhere, and only cars are restricted. We didn't restrict them to where bike lanes are. But there are some implications for pedestrians. So, for example, if pedestrians are jaywalking, we'll assume they took the formal crosswalk. And if we were in a big conference center, and, for example, at TRB, I'm sure a lot of y'all have gone, you could walk a mile inside the TRB conference center. Sometimes that's a little confusing for the pedestrian metrics, and it might lock the sidewalk out front. So those are some caveats with the locking. And if you think you're in a situation where you're running into that caveat in Streetlight Insight, we have some workarounds. Email our support team. So, as Teresa already mentioned, there are a few other caveats about this big data approach. And one of the ones that I think is a strength is that we actually measure all the pedestrian trips, including if you parked your car and then walked a block to your office. That would pick up as a separate walking trip. And that's good because that can lead us to some really interesting trip chain analytics. But we want to be very clear about it so people know what we're comparing. And the other comparison or sort of implication of using machine learning is a little more nuanced. So traditionally for our vehicle metrics, we said, hey, a trip ends if the vehicle stands perfectly still for 5 minutes. And that's very clear. Everybody knows what we mean. But when you're talking about the machine learning-driven approach, the benefit is that you can look at a huge array of features and get far more accurate results. And we tested a lot of different techniques, and machine learning was by far the most accurate. But the weakness is the definition of the trip end and start are a little more flexible and a little more difficult to explain simply. Because the answer of why the trip switched is because the machine said that was the most likely thing that happened, given the millions of points it had analyzed before. And that can be a little less satisfying to our clients. So with some of the validation data, we can get at some of the key questions that usually arise about when are you breaking trips. All right. So as I mentioned, people obviously want to know, well, why should we trust you? You said it was biking us, right? So we did some validation work. I'm going to show you just a few of the examples today in the webinar, and then you can download our bicyclist and pedestrian validation papers, which will all be sent by a link to all participants in the webinar and are widely available if you go to the Streetlight Insight website and click on the validation section, which is just streetlightinsight.com. So first, we wanted to compare at a macro level. So we compared a sample of a couple months of bike trips to the California Household Travel Survey, that's CHTS, and the National Household Travel Survey from 2017, that's NHTS. So the first thing we wanted to show is that our sample size for this aggregate analytic was 86 times larger than the NHTS and much larger than the CHTS. So first we looked at some aggregate analytics like trip distance. So the NHTS found an average bike trip length of 2.38 miles. The streetlight length is 1.1 miles. So you might say, oh, does that mean streetlight is low? We don't think so. A lot of research about the NHTS, especially with the more recent one that didn't have a object recall, shows that it probably highly overestimates or underestimates short trips, misses them. In addition, we are measuring trips so short that they're usually not included in the NHTS. And we'll show you some of the histograms next. So next we compared to the CHTS, and here we're much closer. The CHTS used GPS assist to correct, and one of the main corrections they found was that they also, because of surveys, were undersampling short trips. So this gives us confidence in the high-level results. This is a histogram of the NHTS versus the Streetlight National sample of not just looking at the average, but at the distribution. And as you can see, the reason the streetlight average is shorter is because we have a far higher proportion of very short bike trips. And as I think a lot of us who are bikers know, I make plenty of very short bike trips. And I think this confirms our belief that big data is going to pick up some of those small interstitial trips that maybe are missed in traditional survey techniques. The next validation we did was a micro-validation. So we looked for a city that had a lot of permanent bike counters, and one that we knew pretty well. Luckily, our home city of San Francisco has them. So we looked at, I think, about 50 different bike counters in San Francisco, and we liked these bike counters, A, because they're permanent, so are less prone to factoring up errors that come with semi-permanent counters. And we also like them because they cover a big mix of roads. Some of them are massive, some of them are trails with no cars allowed, and some of them are small roads. And some of them are very hilly, and some of them are very flat. So it really gave us a big variety to compare against. So first, we looked at the permanent counter data and found something, which I think a lot of you experts on the phone know, which is even the permanent bike counter data requires some cleaning. There was a lot of data where we'd see it drop off month to month, and we would be surprised because we live here and we know that nothing changed that much. And then we'd realize that maybe 15 days from the counter were all logged as null. So there was a lot of data cleansing that went in before we started the comparison, and I want to flag that in case y'all are doing your own comparisons. But the next thing we did was a simple R-squared analysis, R counts versus the SFMTA counts for weekdays. And as you can see, it's a very strong relationship, R-squared of 0.8. We were very happy with that result, and that's before any factoring. In the Streetlight Insight app, if you're running bike metrics yourself and you have your own permanent bike counters, you can drop your counts in using our calibration tool. If you haven't not familiar with our calibration tool, basically you put in your own data and it refactors our data to scale it to match yours. So if you have permanent bike counter data or permanent pedestrian counter data, the results from your Streetlight bike ped analysis can be even more useful when you mix them together, which is pretty exciting. All right, so that was a very quick review of our validation work. We have a lot more online. So everyone who's attended or even signed up to this webinar and didn't log in will be sent a link to the recording of the webinar. You'll also be sent a link to download a more detailed methodology and validation document that also goes into all of our pedestrian validation. And there will be ongoing information about our bike and ped analytics at this website. And someone has asked, can you forward these links and information? Absolutely. Forward them to everyone. All right. That concludes our formal presentation, but we're seeing a lot of questions come in. So for our Q&A section, Teresa and I will help answer the questions. But we're also bringing in our bike expert, Sean Coe, who's a special project manager for bike and pedestrian analytics on the Streetlight team as well, in case we get something we can't quite handle. All right. So I'm going to start at the top based on when questions came in, and I'm going to ask the questions and direct it to one of us, including myself. So here we go. So the first question is, I think, about the Lawrence, Kansas example. They said, did the bike lanes we show, were those all bike routes or just class 3? The ones we showed were only the routes with formal painted bike lanes. So I hope that answers the question. So an additional analysis would be, okay, so we have a list of the roads that have the most bikers but no formal bike lanes, then maybe we want to eliminate further or give special consideration to ones that already have sharrows or some other form of bike infrastructure. So they weren't separated bike lanes always, they were green painted on the road bike lanes as well. All right. We have a question about these graphs. So the first question is each point a day? No. Each point is a month, the average daily count for a month of one of the 50-some counters in San Francisco, and we looked at a few different months. So for example, this point is 1 month of one counter, averaged for the streetlight information and the SFMTA information. And the follow-up question was, why is the scale so different? The answer is because we're just giving you the raw sample count here. So we counted, I don't know what this is, let's say 1,700 bike trips at this counter for this month. And the bike counter counted, what is that, 48,000 bike trips, because we're only getting a sample of the data. So this just shows you the correlation of our raw sample count and the SFMTA's raw count. You would use our calibration tool to scale our counts up to an estimated daily bike trips. I hope that was clear. Ooh, good question. Does the GPS data integrate Lime and Bird users? I'll take that one. So if they are Lime bike users, which there's a lot of, well, there was a lot of out here in California, yes, those Lime bike users will be included. If they're e-scooter users, we have not tested for them yet. The nice thing about our machine learning approach is that as new modes of travel start to exist, we can feed them and differentiate out. So our plan is to make formal mode differentiation for e-scooter users and also e-bike users, because we noticed e-bikes were getting confused with motorcycles. So those new modes, along with bus, subway, ferry, airplane, will all be added in the coming months. All right. Let me find some more questions. Q&A. So, we have a question that says, why not have are you going to build a fully integrated planning and monitoring platform? That's a great idea. So, the first step to that is getting to just the core metrics. So that's why we launched these core metrics as soon as they were ready. But we are working with several initial clients, including Caltrans, on basically an ongoing decision support and planning platform that takes into account the specific agency's interest in planning, and also an ongoing monitoring platform for the same. So that is available, and if your agency is interested in that, please let us know. But the first step was being confident in the ability to measure it with reasonable accuracy. All right. I will keep on going down in the Q&A. How small a geography can you operate in? Anybody want to take it?
You can analyze something as small as a roadway, put a gate on a roadway, and analyze passing through that gate. So that's a pretty small geography that you can analyze. Or you can analyze something as big as zip codes across a state if you're interested in understanding bike travel in different zip codes of your state.
Right. I think the other nuance is there's generally fewer bike and pedestrian trips than there are car trips, and there are also fewer bike trips than there are pedestrian trips. So sample size when you're dealing with a smaller thing is always a question, but our tool allows you, if you run into a small sample size, because you're measuring a place without much actual biking, then you can just add more days or more months to the analysis. So we have checked these metrics in very rural areas, and if there's biking, we show it up, and there's always walking, and so that always shows up. So the next question is, Do you have a comparison based on climate conditions to see the trends? Did you do that in the validation report, Sean, or is that coming later?
No. So one of the things that's recommended, even with permanent count locations, is very site-specific and equipment-specific calibration factors. And so we just took the counts from NTA and didn't provide that. There are, the other difference is this is what's occurring right now, and there are a lot of predictive models out there to predict bike trips based on land use, employment, other sort of attractors, including weather, and we're just showing where people are going now. But an adjustment factor like that would be possible. You could run yourself if you had weather information that went back for the period that you were observing.
And also, as we add more months to our tool, if you're a weather-specific place, like a cold place, you can just measure the different months to see the trends yourself. But we have not done a study, but that's a great idea. We could publish that as like a fun blog post in the future. I will say, because a lot of our initial clients were in California, weather was less of an issue. But we are now expanding nationwide. Okay, what is the total sample size of devices? All right. I don't have it off the top of my head. I'm going to go back. So I think this was, the slide you're seeing was one of our first validations where we looked at 1 month of bike riding. So nationwide, we had about 700,000 trips in 1 month of bike riding. Our sample size is increasing very rapidly. Expect some new and exciting announcements in 2 weeks from now about that, and that will also increase our sample size for bike and pedestrian metrics. We have another question about scooters. I can tell scooters are of interest. Yes, we will be adding that as a separate mode in the future. They will not be considered as bikes. They will be their own mode. Another question, similarly, metro riders. So we're going to be rolling out a lot of different modes of travel. Right now, our biggest request from clients was bicycle and pedestrian, so we prioritize those first. The next metric that's available for users who want to take a sneak peek at an early metric is gig driving, so that's Uber, Lyft, Postmates, Instacart. That was our next biggest request. So that's available now if you're interested. Contact us for some preview access. After that, we will be doing bus, train, scooter, ferry, plane. And we will be looking at subways. Subways, because of our big data approach, are the hardest analytics for what we do, because as you all know, depending on different cities, your connectivity with a phone in a subway can be problematic. So in some cities it's totally fine, and in other cities we expect to have some problems. So that is sort of the order in which our modes will be rolling out, and we'll be announcing the launch of each of the new modes via our normal blog and email subscription channels. We have a question, instead of examining bike volumes on existing lanes, could you look at volumes on all roadways? Absolutely. And that's what the Lawrence example does. It looks at all roadways and then looks for the bike lanes and says, okay, where is there a lot of biking on a roadway where there's no bike lane? So you can analyze bike volumes on all roadways, absolutely. A very good question. Unlocking public agency, and this is for Sean, by the way. Unlocking public agency funds is challenging. Can you share some success stories or approaches and how you've been able to monetize these in terms of unlocking agency funds? So you can take it, and then I have a couple examples. You do too.
Well, one of the challenges is in trying to demonstrate that there is, in fact, a demand for bike facilities is trying to quantify how many people are out there. And so there's a variety of ways to do that. I think that the field will agree that they're not the best things. They try to predict where people are going based on sort of these regression models. There are a lot of fund sources, particularly here in California. There's one administered by the state called the Active Transportation Program. It does require you to put your current volumes and then the estimated volumes if the project were to get implemented. So, there's a bunch of ways to do that. But, one of the ways is you could look at the volume of cyclists in an area or in a particular corridor. Back to the question from Jeff, despite a road not having any facilities now, you could cite that as a demand that there are a number of people currently on that roadway, and maybe they would reroute from a parallel facility, but at least you have that data to begin with. There's a lot of, I think there's a lot of, elected officials or decision makers that say, well, there's no facilities out there, there's nobody riding, but in fact, there are people riding. There are people riding bikes, not just during commute times, during midday, at night, at hours that you wouldn't necessarily have people out there observing them.
Yeah. So I think I agree, unlocking public agency funds is challenging. It's also challenging to unlock them to invest in data, which is something we experience all the time. But I think that we have some great case studies out of Virginia. So the Hampton Roads one we showed where they linked biking to tourism was a really strong political argument to unlock some funds. Also in Virginia, we've had a lot of examples where they have a very structured internal competition for investment funds called Smart Steps. So I think I got that right. Yeah, and having good data to show existing patterns, and also having good data to show that, say, improving a particular roadway will help its local neighbors, but also with big data you can say, look, people from 3 neighborhoods away are biking on this road. This has a big impact on the whole community. It's not just about helping out this exact little neighborhood. That's been very useful in their structured competition, and they've sort of built that in, which is a pretty cool approach. And the last way, which I think generalizes what Sean was talking about, which we've been working on with a bunch of clients on bike and pedestrian analytics, is maybe there's $5 million to spend on pedestrian access for transit station upgrades. It can become a sort of circular argument about where they should go. But if you can use data to say, look, there's a ton of 1-mile car trips to the park and ride at this bus station. That's an obvious gap for pedestrian access. Or you can say, look, there's a ton of pedestrian access, but they have to walk 3 blocks down to get to a crosswalk, then cross and walk 3 blocks up. That adds 8 minutes to the walk trip to the metro station. When you can measure those sorts of inefficiencies, it helps triage the investments you want to make. Okay, next question. Examples that your data is used to help urban retailers. Yes, we do. Of course, they're all super secret because the urban retailers don't like to do what they're doing. But many urban retailers use our analytics to understand some pretty basic stuff like how many people will see your storefront if you put it here, and how many of those people will be going as a bike or pedestrian and maybe then could stop in, and how many will be zooming by in a car. So that's the site selection use case for urban retailers is definitely one we work a lot with at Streetlight. But we cannot cite them because they like to keep it anonymous in terms of the brand. Are there how-to guides online to perform an analysis similar to the Lawrence, Kansas example? No, but I will make one next week, and then there will be, and we'll put it in the support center. Because I really like that study. It would be fun to do a March Madness and do bike lane studies and bike utilization studies of like the final four. Okay, that's a really good blog idea. That's definitely going to happen. All right, Sean, another question I think for you. Can you briefly explain how your data could integrate with the travel demand model that are currently being used by, actually, this would be for you too, transit agencies?
Yeah, well, I'll start. So, one of the challenges with travel demand models is they have to be calibrated based on observed data. So there's quite a bit of data out there for vehicles, and we use that to validate our own data by using statewide permanent counters with detectors that are in the roadway. However, there's a big gap for bikes, close to pedestrians. So some of the methods that those travel models would use could be journey to work, census data, or if a region has GPS surveys, but as you saw in Laura's slide, the slide that is up right now, the sample tends to be pretty small. So even if you select, if you have households that, you're not necessarily selecting for people that walk or ride bikes, but again, here in California, you're talking about, 5,900 survey responses representing millions and millions of people. So one way that could feed in is because we're looking at all modes by all trip purposes, you could calibrate a travel demand model with actual real-world data and not rely on survey data that's 10 years old.
I would just add that specifically for transit, for example, right now a lot of transit agencies are experiencing drops in ridership. So I think overall big data can help folks understand things like what is the market of origin destination versus what the transit routes are currently providing in terms of access, but also to understand, transit agencies typically have ridership information for what's happening within their network. So, for example, BART here in the Bay Area has a ridership analysis that helps them understand which station-to-station destinations they have, but they don't really have a lot of real-time information about what's happening beyond their station. So this type of bike and pet data can really help them inform their decisions about providing access and where to prioritize that.
Mm-hmm. Absolutely. Okay, next question, would walking trips inside buildings be noise? So we think we've done a pretty good job of handling that potential for reasonable sized buildings like your house or the streetlight office, because you sort of just walk around in like a little knot of walking trips. But for very big buildings like convention centers and malls, we still have a flag that could cause a bit of noise. We could accidentally think somebody's walking on the sidewalk when in fact they're just walking through a very long mall that's the size of a whole block. So if you have analyses around those places and you think that might be happening, definitely contact support and we can check.
We did have a question also about whether you can extract travel patterns by time of day. And definitely. So all of our metrics are available by time of day, divided by weekdays versus weekends. Everything is customizable in terms of how you slice and dice your data. So both the bike and pet metrics as well as the vehicle metrics and the all mode metrics are all available for segmentation that you would like.
Mm-hmm. Fantastic. All right. I think we've gotten to all the questions. If we didn't, we'll go through and review, and we'll email the person who asked the questions. And it's right at 10:45. So I want to thank everyone so much for attending. This is the start of a lot of really new modal analytics, not just to measure all the modes, but what I think is the most important questions, especially as new modes and ways of being mobile emerge. How do these modes interact? So we look forward to future questions. We look forward to working with you to test it out in your own environment and to start putting these metrics to use with all of our fantastic existing customers and their future customers. I also thank you, Teresa and Sean, for helping me answer the questions. And as we said before, everyone who signed up, even if you didn't actually listen, will get an email with a link to the recording, the slides, and our validation and methodology documentation. And if you are watching this online and did not attend, the email address at the bottom is where all those materials can be found. So thank you so much and have a great weekend.